In the 80s and 90s, orbiting spacecraft used radar to penetrate the acid clouds and map the surface in detail. Without even setting foot on the planet, scientists had seen a landscape beyond their wildest imagination. Its surface is littered with volcanic cones and lava flows. The temperature on the surface of Venus is hot enough to melt lead. The atmospheric pressure is so great it would crush a tin can. It's unlikely that we would ever want to set foot here. It may be well into the 21st century before we can visit even the more hospitable of the planets. For most planetary scientists, the best method of trying to understand what conditions are like on the surface of other planets is to compare them with the similar terrain here on Earth. Our planet is peppered with volcanic structures, features that can help to unravel the mysteries of distant worlds. For John Spencer from the Lowell Observatory in Flagstaff, Arizona, this flight over his local volcanic lava field is like flying over Venus or Mars.
We're now looking at another absolutely gorgeous example of a cinder cone and a lava flow. You can see the crater in the center and the big pile of cinders around the outside. And then coming out here at the base and spreading out for several miles is a thick lava flow going to other planets where all we can really see is the shape. We can't go down on the surface and sample the rock. We can still tell what the composition of the volcanoes is and something about their history just by looking at their shapes.
This group of recently active volcanoes in northern Arizona has spewed dark basaltic lavas from beneath the Earth's crust onto the surface.
Seeing lava flows coming away from craters like this is a surefire sign that we're looking at volcanic activity, whether we see it here on the Earth or whether we're seeing it elsewhere in the solar system.
Volcanoes help create the oceans and our atmosphere. If we can find volcanic structures like this on Mars, we can speculate that once it may have looked more like Earth. When the first spacecraft flew past Mars, the evidence for volcanic activity was unequivocal. Images beamed back revealed structures very similar to those the scientists could see on Earth. These cones are thought to be dead now, but the evidence of an active past is everywhere. Mars boasts the largest volcanoes in the solar system. This is Valles Marineris, the largest rift in the solar system. If it were here on Earth, it would stretch across the Atlantic. It's a giant scar, evidence of a dynamic past when the Martian crust was torn apart. This is the Jet Propulsion Laboratory at Pasadena, California, home of NASA's unmanned space missions. The task of getting the first mobile rover to land safely onto the surface of Mars was the responsibility of JPL's Rob Manning. Manning and his colleagues had spent years designing and building a new robotic rover called Sojourner. It would be the first vehicle that NASA had landed on another planet for over 2 decades.
Going to Mars for the first time in 20 years was a challenge because a lot of the people who knew how to go to Mars and land on Mars were dead or retired. So we had to go back to the drawing boards and really figure out, again, from first principles, how to bring a lander to another planet.
Manning's young team decided on a radical new way to land. To save money, Sojourner will be dropped down onto Mars inside inflatable airbags.
Engine start 1, 0, and liftoff of the Delta rocket with Mars Pathfinder. And the vehicle has cleared the tower.
After a 7-month flight, the Pathfinder mission made its final approach. Manning and his team were about to discover if their unique method of landing would work.
The next event is lander separation. That should occur in about 5 seconds.
Sojourner rocketed down through the thin Martian atmosphere and survived at least 15 bone-jarring bounces. Sojourner had come to a stop precisely on target. Years of hard work had paid off. For Manning, it was a moment of pure ecstasy. For the first time in a generation, NASA had returned to Mars.
Once the pedals opened up, and the next day, when we finally got Sojourner to stand up and roll down the ramps, for the first time, we had a mobile robot, a mobile laboratory, a mobile geologist that go out and explore another planet.
For the men and women who drove Sojourner from tens of millions of miles away, this was the next best thing to being there.
Operating your rover and lander on another planet, it feels like an extension of yourself. You really feel that you are there. Every day when we came to work, we went to Mars and we saw it for ourselves. It felt like an extension of our hands and eyes. And so it was very exciting. We knew what that landing site felt like to be there.
The Pathfinder mission had landed Sojourner in an area thought to be an ancient floodplain. As it roamed the surface for 84 days, it examined the boulders and discovered that Mars was covered with many different types of volcanic rocks. In 2003, NASA plans one of their most spectacular of all missions. This flight will happen exactly 100 years after the Wright brothers flew their first plane on Earth. The Mars airplane will fly to the most inaccessible regions where life might have existed and photograph them from the air. But for some people, robotic explorers aren't enough. They believe that true exploration can only be made by humans.
Have you ever seen a robot have a ticker tape parade in New York City? No. That's the big difference. We must go. It's within us to go. The question we ask about what is it like, what does it feel like, what does it look like, are questions people can relate to only through a human being, not through a robot, not through a camera, not through a computer chip.